Good morning, and once again, welcome to my YouTube channel, Pearson at Excel International Maths. We are looking at example 12 of logs, exponential and logs of pure mathematics 2, exponential and logs. We are looking at example 12 of P2 exponential and logs. That is topic number 3, chapter 3. And we are faced by a question which is 5 raised to power 2x minus 12 raised to power x plus 12 5 raised to power x plus 20 is equals to 0. And if you look at this equation keenly, you will see there is something that you may relate with. There is something to do with quadratic equations. So it is a quadratic equation of the function 5 raised to power x. So if you talk about, if you now want to use laws of indices here, you might even say 5 raised to power x and squared. If you take 5 raised to power x to be just y or any variable, minus 12, 5 raised to power x plus 20 is equals to 0. So at that point we say let 5 raised to power x be y. And the moment we introduce y, we have y squared, because 5 raised to power x is y, minus 12y, because the same 5x is here, plus 20 is equals to 0. The reason why we introduce y is the variable and leave x, because x was in the index position, and the moment we realize that it's going to be a quadratic equation, we have been able now to rewrite it in such a way that it suits a perfect quadratic equation, because the law of indices dictates that 5 raised to power 2x is the same as 5 raised to power x into bracket squared, because this is just the product of this. And having let y to be 5 raised to power x, then we can now solve it as a quadratic equation using factorization method. And let's talk about the BAC method. You can talk about BAC. What is the B? Minus 12, and what is AC is 20. Two numbers you multiply, they give us 20, and you add, they give you minus 12. Of course, this is minus 10 times minus 2, and minus 10 plus minus 2 is simply minus 12. So substituting the middle term, we have y squared minus 10y minus 2y plus 20 is 0. Y is common in the first two, y minus 10, and then this negative follows, and 2 is common. In the bracket again you have y minus 10 is 0. So it's either we have y minus 10, y minus 2 multiplied together giving you 0, and this one gives us y minus 10 is equals to 0. If this is true, y is equals to 10. Or we could have this other bracket being equals to 0, y minus 2 being equals to 0, and if this is true, y is equals to a positive 2. But remember, we were not looking for y, we were looking for x. So we say, but y is equals to 5 raised to power x. So in other words, 5 raised to power x is 10, and we can simply introduce log to base 5 on both sides, so that we can have x is equals to log to base 5 of 10. I hope you see this one. I have omitted a step. We would have said log to base 5 of 5 raised to power x is equals to log to base 5 of 10, such that the x will be now a coefficient and log to base 5 of 5 will be 1. So x times 1 will remain 1. So at this point now you can simply use this button, introduce base, and then we go to 10 and we go to equals to, which is 1.43. So if this is true, then x is equals to 1.43. But when y is 2, when y is 2, when y is equals to 2, we can simply say that 5 raised to power x can also be equals to 2. And allow me now to introduce log to base 10 directly on both sides. For those of us who do not have the calculators that can allow you to select the base, and you're going to have this one, log to base 10 of 5 raised to power x is equals to log to base 10 of 2. And this is just now using the power law of index. We have x log to base 10 of 5 is equals to log to base 10 of 2. By the way, when you're using the natural logarithm of the button, not the natural logarithm, because the natural logarithm is ln, the button of log, you don't need to indicate base 10 because the calculator realizes it's obviously base 10. So if you divide both sides by log of 5, both sides by log of 5, you would say x is equals, because that will cancel with that, is equals to log 10, which log base 10 of 2, meaning the logarithm of 2 divided by the logarithm of 5, and that would be just that 0 0.4, 0.431. That is the value of x at that particular point. That is the other value of x, possible value of x, and that is just like it as far as that one is concerned. Yes, example 12, very good. Please follow, subscribe, and share widely so that